Welcome to AIM 10. In this AIM, we are going to discuss about parallelogram. Parallelogram. Parallelogram means a quadrilateral in which both pairs of opposite sides are parallel. Let me write that definition. A quadrilateral in which both pairs of opposite sides are parallel. Then it is called the parallelogram. Now let me draw the figure of parallelogram. See, this is the parallelogram. While we are drawing the parallelogram, we have to observe that their opposite sides should be parallel. Here ABCD is a parallelogram. In this, what are the opposite sides? AB and CD are the opposite sides. AD and BC are the opposite sides. According to our definition, they are parallel to each other. See here, this is parallel to this one and this one is parallel to this one. So here in this quadrilateral, both pairs of opposite sides are parallel. So we can say that is a parallelogram. Let us see now some properties of a parallelogram. These properties are very important. Properties of a parallelogram. The first most important property is that in a parallelogram, opposite sides are equal. What is that? First one is opposite sides are equal. Opposite sides are equal. Means what are the opposite sides in that parallelogram? AB and CD. Those two are equal. At the same time, AD is equal to BC. Why? Because this is another pair of opposite side. And the second property is that opposite angles also equal. Opposite angles are equal. What are the opposite angles in this figure? A opposite angle is C, B opposite angle is D. They are equal. Let me write here. Angle A is equal to angle C and angle B is equal to angle D. The first two properties of a parallelogram are opposite sides are equal. At the same time, opposite angles are also equal. Now let me explain about the third property. That is, how many diagonals can we draw in a parallelogram? Yes, we can draw two diagonals in a parallelogram. See, this is one diagonal, BD, and if you join AC, that is the second diagonal. Observe here, here I drawn one diagonal. This diagonal divides the parallelogram into two triangles. What are they? A, B, D is one triangle, B, C, D is another triangle. So here we can say each diagonal of a parallelogram divides that into two triangles. That too, those two triangles are congruent. So we can say each diagonal of a parallelogram divides the parallelogram into two congruent triangles. This is the most important property, which is third one. Now let me write. The third property is each diagonal of a parallelogram divides the parallelogram into two congruent triangles. Two congruent triangles. See here, what are the congruent triangles in this figure? Yes, here BD is the diagonal. It divides the parallelogram into two congruent triangles. They are A, B, D and B, C, D. Both are congruent to each other. And the next property of the parallelogram is, in a parallelogram, diagonals are bisect each other. Let me draw one more diagonal here. See here, in this figure, you can see two diagonals. Those two diagonals are meeting at the point O. What I am saying? Diagonals are bisect each other. Diagonals bisect each other means, observe here, this is the intersecting point. See here, OA is equal to OC and OD is equal to OB. Bisect means that point they are dividing themselves into equal parts. Here OA is equal to OC and OD is equal to OB. This is the meaning of bisector. And let me write that point. In a parallelogram, diagonals are bisect each other. In a parallelogram, diagonals are bisect each other. This is the most important property. And here one more important property what you have to remember is, here diagonals are bisect each other, but diagonals are not equal. Diagonals are not equal. And now let me tell you one more property, that is fifth one, that is, in any quadrilateral, one pair of opposite sides are parallel and equal, then we can say it is a parallelogram. Let me repeat the fifth property. In a parallelogram, one pair of opposite sides are parallel and also equal, then we can say it is a parallelogram. And let me tell you the sixth property now. The very important sixth property is here, sum of the squares of the sides is equal to the sum of the squares of the diagonals. What are the sides here? AB, BC, CD and AD. These are the sides. Now I am saying sum of the squares of the sides means AB square plus BC square plus CD square plus AD square. All these four are sides. Sum of the squares of the sides is equal to the sum of the squares of the diagonals. What are the diagonals in the figure? Yes, AC and BD are the diagonals. Now let me write AC square plus BD square. This means sum of the squares of the diagonals. So very important property in a parallelogram. And next one is, suppose take any quadrilateral. If you join the successive midpoints of the sides, definitely it forms a parallelogram. Means in a quadrilateral, by joining successive midpoints. Successive midpoints of sides forms a parallelogram. Forms a parallelogram. Let me show how it is. Suppose I am going to take here one quadrilateral. This is the quadrilateral A, B, C and D. Now I am taking midpoints of their sides, and here I am taking this midpoint, let it be K, and here L, and here M, and here it is N. Here K, L, M and N are the midpoints of the sides of AB, BC, CD and AD respectively. Now let me join these midpoints successively like this. Yes. Now the figure K, L, M, N is parallelogram. Actually here we have the proof. How can we say KLMN is a parallelogram? But that proof you will be learn in your coming classes. And here KLMN is a parallelogram where A, B, C, D is a quadrilateral. And the next important property. Now take parallelogram. In a parallelogram, if you join the successive midpoints of the sides, definitely that resultant figure also will be a parallelogram. Quadrilateral midpoints, if you join the midpoints of the quadrilateral, it is a parallelogram. Again if you take parallelogram and again join the midpoints of the parallelogram, definitely it will be also forms a parallelogram. And don't forget that you have to join the successive midpoints only, like this, and you need not to join zigzagly. You don't join like that. Okay, this is the very important properties of a parallelogram. And now let me go with another type of quadrilateral, that is rectangle. And the second one is in the same rectangle. How rectangle will form? In a parallelogram, one angle is 90 degrees, then it becomes a rectangle. In a parallelogram, one angle is 90 degrees, then it becomes a rectangle. How rectangle? Yes, the shape of the rectangle is like this. What is its properties? Now let me give the name A, B, C, D. Now let me write the properties of rectangle. Properties of rectangle are, in a rectangle, opposite sides are equal. Rectangle should satisfy all the properties of parallelogram. Rectangle can satisfy all the properties of a parallelogram. So here also opposite sides are equal, which means AB is equal to CD and AD is equal to BC. First one, opposite sides are equal. Opposite sides are equal. They are AB is equal to CD and BC is equal to AD. And the second one, opposite angles are equal. Not only opposite angles, and here if you take any angle, each angle is equal to 90 degrees. Here 90, here 90, here 90. All angles will be 90 only. If you observe opposite angles, they are also equal. Simply we can say all angles are equal also here. Each angle representing 90 degrees. And the next one is, here also we can draw a diagonals. How many diagonals we can draw? Of course, 2 diagonals. Here each diagonal divides the parallelogram into 2 congruent right triangles. Here see why I am saying this is a right triangle means here one angle is 90 degrees. So each diagonal divides the rectangle into 2 congruent right triangles. And we can say here also diagonals are bisect each other. Like parallelogram, in rectangle also diagonals are bisect each other. And the next one, very important thing, the difference between the parallelogram and rectangle is, in parallelogram length of the diagonals are not equal, whereas in rectangle length of the diagonals are equal. Diagonals are in equal length. Diagonals are equal. Diagonals are equal. Now here also add the adjacent angles. Here what are the adjacent angles? A, B, B, C, C, D, D, A. If you take the sum of the adjacent angles, definitely it will be equal to the 180 degrees. In parallelogram also, sum of the adjacent angles are 180 degrees, whereas in rectangle also sum of the adjacent angles is 180 degrees, which means angle A plus angle B is equal to 180, angle B plus angle C is equal to 180, angle C plus angle D is equal to 180, angle D plus angle A also 180. This is also one of the important property in a rectangle as well as in parallelogram also. And this is about the rectangle. Now let me explain rhombus. What is a rhombus? Rhombus. What is a rhombus? Rhombus, how can rhombus form? In a parallelogram, adjacent sides are equal. In a parallelogram, adjacent sides are equal. Then it is said to be a rhombus. So let us see the properties of rhombus. Before going to the properties, let me explain about the, let me draw the rhombus figure. This is the rhombus. A, B, C and D. And here AC, comma, BD are the diagonals of a rhombus. They are intersecting at point O. And the first important property of rhombus is, in rhombus all sides are equal. In rhombus all sides are equal. Properties of rhombus. The first one is all sides are equal. That means AB is equal to BC is equal to CD is equal to AD. All sides are equal means. And next, second one is, in rhombus we can draw two diagonals. Those two diagonals are bisect perpendicularly, bisect each other at perpendicular. Diagonals in a rhombus, diagonals bisect each other perpendicularly. See here, perpendicular means making angle 90 degrees. Always in rhombus, diagonals are bisect each other perpendicularly. At the same time, here OB is equal to OD, AO is equal to OC. Bisect means here to here length, here to here length are equal. OB is equal to OD, AO is equal to OC. And in rhombus, diagonals are not equal. Whereas in rectangle, diagonals are equal, but here in rhombus, diagonals are not equal. Means the length of the diagonals are not equal. Diagonals are not equal. Sum of the adjacent angles here also 180 degrees. If you add angle A plus angle D, it will be gives 180 degrees. Angle D plus angle C also 180 degrees. Sum of the adjacent angles. Sum of the adjacent angles is 180 degrees. And now each diagonal divides the rhombus into two isosceles triangle, two congruent isosceles triangle. Why I am saying isosceles triangle means, see here I am drawing one more rhombus here. Suppose let me take one diagonal only here, and we know all sides are equal. Let it be A, B, C, D. See, this is the diagonal. It divides the rhombus into two triangles. Observe, in this triangle these two sides are equal. In this triangle also these two sides are equal. In any triangle two sides are equal, we can say isosceles triangle, no? So that's why each diagonal of a rhombus divides the rhombus into two congruent isosceles triangle. And the next one, fifth property, each diagonal divides the rhombus into two congruent isosceles triangles. Isosceles triangles. And next, here if you observe, each diagonal divides the angles into equal parts, which means here BD bisects angle B and angle D, AC bisects angle A and angle C. Each diagonal bisects their angles. BD bisects angle B comma angle D, and AC bisects angle A comma angle C. And here one more property I am going to add, that is two diagonals divides the rhombus. Two diagonals divides the rhombus into four congruent triangles. Let me count. This is the first triangle, this is the second triangle, this is the third triangle, this is the fourth triangle. Both diagonals divides the rhombus into four triangles. Those four triangles are congruent to each other. This is the specialty of the rhombus. And let me recall you, in rhombus all sides are equal. And the second property is sum of the adjacent angles are 180. And the next one is each diagonal divides the rhombus into two isosceles congruent triangles. And the next property is diagonals are bisect each other at right angle, means perpendicular. And here both the diagonals divides the rhombus into four congruent triangles. And next, here in this rhombus diagonals are not equal, but they are bisect each other at perpendicularly. Diagonals are not equal. So in this way we can say the properties of rhombus. And now let me explain square. Now I am going to explain about the square. What is a square? In a rhombus, one angle is equal to 90 degrees. In a rhombus, one angle is equal to 90 degrees. Then it is said to be square. Otherwise, in a rectangle, adjacent sides are equal. Pair of adjacent sides are equal. Then also we can say it forms a square. How square will be? Let me draw now. This is the square. This is said to be square. Let me give the names A, B, C and D. A, B, C, D is a square. What are the properties of square? Now let me explain its properties. The first property of the square is, all we know, in square all sides are equal, all angles also equal. Each angle is 90 degrees. Each angle is 90 degrees. Now let me write, all sides and angles equal. All sides and angles are equal, which means AB is equal to BC is equal to CD is equal to AD. And here also in square we can draw two diagonals. Here also those two diagonals are equal and they are bisect each other at a right angle. At right angle, let it be O here. And see, diagonals are equal. Diagonals are equal. And the next property is diagonals bisect each other at right angle. Diagonals bisect each other perpendicularly. Perpendicularly at the 90 degrees, at 90 degrees, at right angle, all are same. And now the next property, each diagonal divides the square into two isosceles right angle triangle. Let me draw one more figure to show you. See, here this is a square, AB, CD. Now let me join AC, and here we know this is 90 and here also 90. All angles are 90 only. Observe here, this diagonal divides the square into two triangles. In square all sides are equal, no? Observe the each triangle. This is the triangle. What type of triangle is this? Here two sides are equal and one angle is 90 degrees. Two sides are equal, one angle is 90 degrees, means that is called isosceles right angle triangle. Up also that only, no? So here we can write each diagonal divides the square into two isosceles right angle triangles which are congruent to each other, which are congruent. This is the very important properties of a square. Now let me recall, in a square all sides are equal, all angles are equal. Each diagonal divides the square into two congruent isosceles right angle triangles, and both the diagonals are equal in length, and both the diagonals are bisect each other at right angles. Bisect means we know, and here OA is equal to OC, OD is equal to OB. And next we can say, here we can add one more property here. Sum of the adjacent angles always supplementary, means 180 degree. Now let me explain one more property here. Take square here, and now join their successive midpoints. I am taking here the midpoints of the sides. If you join the successive midpoints of the sides of a square, then the resultant figure will be also a square. If you join the successive midpoints of a square, the resultant figure also be square. Let me give the name here: K, L, M and N. Here A, B, C, D is a square. K, L, M, N are the midpoints of A, B, B, C, C, D and D, A respectively. If you join those, then the resultant figure K, L, M, N is also a square. And this is the very important property, and this is about the square. And now let me explain some important points which are very useful to solve our problems, and which are very important to discuss here. Now let me tell you. They are: first important note, that is, in a rectangle, I am taking one rectangle here, that is A, B, C and D. Take the angular bisectors, and here it is A, and it is B, and it is C, and it is D. No? Now take the angular bisectors of all like this. If the angular bisectors all meeting at some K, L, M, N, what this figure says? What this figure says? Yes, here K, L, M, N is a parallelogram. In a rectangle, the bisectors of the angles forms a parallelogram. Here K, L, M, N is a parallelogram. And next, let me take one more rectangle here. I am taking one more rectangle here. I am taking one point which is O, that is inside of the rectangle. Let me give the name here, A, B, C and D. Now join here OA, OB, OC and OD, and here OA plus OC is equal to OB plus OD. Here I can write the property OA plus OC is equal to OB plus OD. These are also very important properties. Now let me explain some important properties in this A. Note. Take a parallelogram now. I am taking parallelogram here. Suppose A, B, C, D is a parallelogram. A parallelogram can have 4 angles. Now take the angular bisectors of these angles. These only know. These are the angular bisectors. Let them join at K, L, M, N points. And here one shape formed now. Here K, L, M, N is the rectangle. Here ABCD is a parallelogram. And here K, L, M, N is a rectangle. So we can say the angular bisectors of a parallelogram forms a rectangle. This is also one of the important property. Angular bisectors of a parallelogram forms rectangle. And now let me explain one more important property. Now I am going to take rectangle. This is the rectangle. I am taking one interior point which is O. Interior point means the point which is inside of the rectangle. Here O is the interior point of this rectangle. Let me give the name of rectangle A, B, C, D. Now join OA, OB, OC and OD. The relation between OA, OB, OC, OD are like this. OA square plus OC square is equal to OB square plus OD square. This is also one of the important property. And now I am going to take again one rectangle. This is the rectangle ABCD, no? I am taking this one. Here each diagonal, we know, divides the rectangle into 2 congruent right angle triangles. And moreover, here we can say the square of the diagonal of a rectangle, the square of the diagonal of a rectangle is equal to the sum of the squares of the other 2 sides. Simply, it is right angle triangle, no? Just I applied Pythagorean theorem here. That is, from this I can say, from here onwards I can say AC square is equal to AB square plus BC square. Otherwise, AC square is equal to, or I can write AC square is equal to AD square plus CD square also. Similarly, if you take the diagonal BD, then you can also apply this property there. And now the next important property. Now I am going to take here two parallel lines. See here, these are two parallel lines. Between these two parallels, I am going to take two parallelograms which have the same base. And now this is, let me give the name, A, B, C, D is a parallelogram. And let me take one more parallelogram here, that is with the same base, A, B, E, F. In this figure we have two parallelograms. They are A, B, C, D. A, B, C, D. Parallelogram A, B, C, D and parallelogram A, B, E, F. You can see two parallelograms. What I am going to say is, if any two parallelograms are between the same parallel lines and have a common base. Two parallelograms have the same base between the same parallel lines are equal in area. Means area of this parallelogram always equal to the area of this parallelogram. Now let me write here area, shortcut form AR we can write. Area of parallelogram ABCD is equal to area of parallelogram ABEF. This is also very important property. The parallelograms which have the same base between the same parallel lines are equal in area. And now let me go with one more important property. And here also I am going to take two parallel lines. Between two parallel lines, I am taking one parallelogram, that is A, B, C, D, and also I am going to take one triangle which is ABC, ABCD over now E, let it be E. See, in this figure you can see ABCD is a parallelogram. Parallelogram ABCD, and you can see triangle ABE. What is the common thing in these two? The base of the triangle and the base of the parallelogram is equal, which is AB. Triangle base is AB and ABCD, one of the side also AB, which is called base. A parallelogram and a triangle have the same base between the same parallel lines. Yes, these two are between same parallel lines, no? Then how their areas will be? Let me show you. Then area of parallelogram ABCD is twice the area of triangle ABE. Otherwise we can say area of triangle ABE is equal to the half of the area of the parallelogram ABCD. I am repeating, a triangle and a parallelogram have the same base between the same parallel lines and their areas, means area of the parallelogram always double the area of the triangle. Otherwise area of the triangle is half of the area of the parallelogram. So this is also one of the useful property. And now we saw the quadrilateral formed by joining the successive midpoints of a parallelogram is parallelogram. Square is square. What about rectangle? Yes, rectangle forms rhombus. Rhombus forms rectangle. These are the important. Let me recall you. The quadrilateral forms by joining the successive midpoints of any quadrilateral is parallelogram. And the second one, the quadrilateral formed by joining the successive midpoints of a parallelogram is also a parallelogram. Now, next one, the quadrilateral formed by the joining successive midpoints of a rhombus is rectangle. Next one, the quadrilateral formed by the joining successive midpoints of a rhombus is rectangle. Rectangle is rhombus. Square is square only. These are very important properties which are very useful to solve our problems. And now let me solve some problems from our aim now. Now I am going to take the problem. Here ABCD is a parallelogram. They given ABCD is a parallelogram. LLGM is shortcut of parallelogram. If AB is equal to 2AD, they given condition. If AB is equal to 2AD and P is the midpoint of AB and P is the midpoint of AB. Prove that P dot D means P dot T means prove that angle CPD is equal to 90 degrees. Angle CPD is equal to 90 degrees. And here they given figure also. That is, they given one parallelogram. A, B, C, D. And here they given, here P is the midpoint. P is the midpoint means which divides the AB into two equal parts. And they this is the figure what they given. And here they want to prove here angle is 90 degrees. We have to prove here angle is 90. Now let me solve this problem. Very easy, and we have to think logically. First of all, what is the given? ABCD is a parallelogram. Given that ABCD is a parallelogram. What is the one of the property of parallelogram? In parallelogram, opposite sides are equal, which means AB is equal to CD, AD is equal to BC. So we can write like that. AB is equal to CD and AD is equal to BC. In problem they given one condition, that is AB is equal to 2AD, and also they given P is the midpoint. P is the midpoint. P is the midpoint means AP is equal to PB. AP is equal to PB. See now, here they given AB is equal to 2 AD na, means this full AB is equal to 2 into AD, means AP is equal to AD, PB is equal to AD, we can write now? Yes. So I can write here AP is equal to AD and PB is equal to AD. Now see here, AP is equal to AD means here and here equal, and PB also equal to AD na. PB is equal to AD means automatically AD equal to BC no, from our here PB is equal to AD. In the place of AD I can write BC. So automatically from here PB is equal to BC also no, means here side equal to here side and here side equal to here side. Remember the one of the property in the triangles, the angles which are opposite to the equal sides are equal. The angles which are opposite to the equal sides are equal. See here in this triangle, here this is the triangle which is APD. Here opposite angle is this one, opposite angle is this one, and this one opposite angle is this one, and both are equal. Let me say it is X and it is also X, and same property I am applying here also, and here we can say it is Y and here it is also Y, right? Here both angles are equal, and we know one of the important property in the parallelogram. In a parallelogram, adjacent angles are, sum of the adjacent angles are 180 degrees. Sum of the adjacent angles are 180 degrees. So I can write here angle A plus angle B is equal to 180 degrees. Angle A plus angle B is equal to 180 degrees. Here A comma B are the adjacent angles of a parallelogram. What is A? We have to find out that A. Now let me find out the angle A. From triangle APD, we know sum of the three angles equal to 180 degrees. So let me find out that one roughly. See here, from triangle APD, angle A plus X is equal to 180 degrees. So from here angle A is equal to 180 minus 2x only, no? X plus X, 2x, the 2x going that side, minus 2x. So I can write in the place of angle A 180 minus 2x, no? Similarly here also. This is also from triangle PBC. In this triangle also, sum of the three angles will be equal to 180 degrees. That means angle B plus Y is equal to 180. From here angle B is equal to 180 minus 2y. Let me write these two here. In the place of A I am going to write 180 minus 2x. In the place of B I am going to write 180 minus 2y. Let me erase this one. See here, which is equal to 180 degrees, and this 180 cancel, and now 180 degrees is equal to minus 2x minus 2y going that side, plus 2x plus 2y. Now let me common 2 here. If I common 2 into x plus y is equal to 180 degrees, x plus y is equal to 90 degrees. 2 90 times will cancel. What is x plus y? This one, no? If you add this angle and this angle, definitely it will be 90 degrees. We got it. What about this one? Here you can see angle BPC plus angle CPD plus angle DPA forms linear pair. Why? Because these three angles are on the line. Linear pair means angle equal to 180 degrees. Now here we can write x plus y plus angle CPD is equal to 180 degrees. Why? Because they are linear pair. In bracket we have to write linear pair. Now we know the value of x plus y, that is 90 degrees. That plus 90 going that side, minus 90. Angle CPD is equal to, this value will be 90 degrees, no? It will be go that side, minus 90. 180 minus 90 degrees will give 90 degrees. That only now we have to prove angle CPD is equal to 90 degrees. In this way we can prove these problems. Thank you.